Hi folks, we're going to talk for a minute on two-body problems. Now, two-body problems intimately related to tension because they are two or more objects that are all tied together. Now, this picture on the right-hand side is the beginnings of a drawing. Let's pretend the big blue box is a table or some sort of a supporting surface. And I've got mass number 1 and mass number 2, and these are attached together by some sort of a rope or cable. As we've talked about tension in the past, if there is no slack anywhere in that rope, then the tension is going to be the same at every point within that rope. Now, if these two things are attached together, and if I've got a pulley that's free to rotate, what's going to happen is when I let mass 2 fall, it's going to pull mass 1 off the table. Now, if mass 2 was in a free fall situation and it could just drop, if it could just drop, then it would be accelerated at 9.8 meters per second squared, but it can't. It's pulling mass 1 behind it. Because of that, this is going to slow mass 2 down. Now, if the two are attached and there's no slack in the string, the acceleration is going to be the same for both objects. This gets a little wacky when you start doing two-body problems. The direction of motion is positive, and the direction of motion is different because everything we've done so far has been left and right or up and down. Now we've got things moving in a weird curve. So the direction of motion is actually falling off the table in this problem. So I'm going to call anything that pulls the whole system off the table positive, and anything that opposes that I'm going to call negative. When you're doing a two-body problem, you have to draw all the forces on each mass and then sum the forces on each object. So let's go ahead and draw the forces. On mass 1, I'm going to have the force of gravity on object 1. I'm going to have the normal force, which is normal force of object 1, but this one's not sitting on a table, so that's my only normal force. Tension is pulling it to the right, and friction force is going to the left. So those are my 4 forces on block 1. Mass 2 only has 2 forces. Force of gravity on block 2, and then upward tension is acting in that direction. Now, when you sum the forces on these objects, oh, I was looking for my eraser. Hold on, let me grab my eraser here and erase this mess. When you sum the forces on these objects, you have to sum the forces on block 1 in the vertical direction, sum the forces on block 1 in the horizontal direction, and then you have to sum the forces on block 2. So you're actually going to have 3 columns of equations, and then you're going to solve from there. So that's a little introduction to two-body problems. We're going to do a couple examples next. See you then.